Human vision is a poor assistant in studying distant worlds. That's why inventors on Earth have spent centuries making spyglasses and telescopes, whose eyepieces defy distance and help us look deep into the universe. Scientific advances eventually enabled spacecraft with cameras to reach planetary surfaces in the solar system. Thanks to them, we were able to see with our own eyes mysterious craters, unexplored valleys, rugged cliffs, and other details of alien landscapes. Mars is the favorite when it comes to exploration. It has received more visitors from Earth than any other planet. So what did they see on this barren and gloomy yet so alluring planet? Here is a unique collage of Martian images taken from the catalogs of various missions that have ever visited this rocky celestial body. Hello, subscribe. This image shows an outcrop of thinly layered rocks in the Murray Buttes area on Mount Sharp. This image shows thinly layered rocks in the same place. You can see a slope in the Murray Buttes area of Mount Sharp. In this image, you can see slanted edges and a multi-layered outcrop in the Murray Buttes area. And here is a map showing the route taken by the rover from the place where it landed in August 2012 to the location where the rover was in early March 2016. Did you know the sand on Mars is unique and unlike Earth's sand? The proof of this is the relief-textured sandstone on Mount Sharp. These are pieces of Martian soil, visible in the lower, left, and upper parts of the image. You can even look at it under a microscope, just like the Phoenix lander once did. Here's a close-up of Martian sand grains. At night, National Aeronautics and Space Administration used electric lamps to better illuminate the regolith particles. This is the leeward side of the Namib sand dune, but doesn't it look just like Africa? Marias Pass, the contact zone of two Martian rock formations, photographed on May 22, 2015. Now let's take a look at the side of Mount Bagnold. This image, taken from Mars orbit, shows a sand dune, the first one the rover will visit. The animation shows the movement of the dunes, recorded in 2010 and 2014. And here is the city of Sad, near Mount Sharp. The probe's camera showed a network of mineral veins beneath the ridge of bedrock on Mount Sharp on March 27, 2015. The next image shows dark material with different chemical compositions found in the mineral veins of the city of Sad. Take a closer look. In front of you is a dark, thin material filling the cracks in the ground. This is a group of images overlaid histograms using the Chemistry and Camera ChemCam tool. As you can see in this image, the mineral veins at the Garden City site vary in thickness and brightness. Here, a geological contact is recorded where the pale rock meets the darker overlying hill. The photo was taken on May 21, 2015. What could be more beautiful than a sunset in a Martian crater? Probably only the Earth rover recorded this sequence of images of the setting sun at sunset on the 956th Sol. This map shows the route passing along Mount Sharp. The green star marks the rover's location after the trip on April 16, 2015. The map covers an area about 2 kilometers wide. And now let's observe the life of robots. The rover's environmental monitoring station includes temperature and humidity sensors mounted on the rover's mast. This image is a close-up of a two-toned mineral vein at a location called Garden City on Mount Sharp. And where is the rover? Has it gotten lost? The rover can be seen in this image in the Pahrump Hills area of Gale Crater. This photograph, taken on January 13, 2015, shows the results of a mini drill test needed to assess the Mojave rock. Now the rover knows whether it can drill to full depth to collect samples. This chart shows a comparison between the amount of an organic chemical called chlorobenzene found in the Cumberland rock sample and its amount in fragments of 3 other types of Martian surfaces. Now you will visit the bottom of an ancient body of water. The features of the channel of a dead Martian lake show a typical pattern of sedimentary bottom deposits near the place where water flowed into the body of water. This series of images reconstructs the geology of the region around Mount Sharp, where the rover landed. The images were altered to illustrate how deposits can accumulate during alternating dry and wet periods. The image shows an example of a thinly layered, evenly stratified type of rock found in the Pahrump Hills outcrop at the base of Mount Sharp. This type of stone can form under the surface of a lake. Diamond-shaped crystals are visible in this magnified image of a Martian rock called Mojave. These features record the concentration of dissolved salts, presumably in a drying lake. This image shows an example of crossbedding, which occurs as water flows through a loose layer of sediment. In the foreground, several layers of sandstone show a systematic southward dip, indicating the gradual buildup of deltaic deposits in that direction. Mount Sharp. And now, let's turn our eyes to the sky. The rover observes comet sighting spring, passing near the red planet on October 19, 2014. This image shows clear bands of alternating brightness within the Murray Formation on Mars. Such bands are quite common, although their origin is unknown. The image shows a mesa in the Murray Buttes area. And the last image, a pit in the Martian soil during repeated laser shots from the Mars rover. This slow-motion 16-frame film shows how repeated laser shots lead to the formation of a pit in the Martian soil. The area of soil included in the image is about 28 millimeters across. After looking through all the suggested images, a person who has never visited Mars can get a rough idea of what landscapes await the colonists who dare to settle on the red planet. Not a very hospitable landscape, is it? And the weather isn't pleasant either. Perhaps the only consolation is that after thousands of years, we might be able to terraform our dusty neighbor and turn it into a clone of Earth. So, until that happens, make sure to enjoy the authentic Martian landscapes while you still can. The panoramic scene was created from over 1,000 Mastcam camera images. Behind the rover, you can see areas rich in clay rock, which indicate that there was a watery environment on Mars in ancient times. The images used to create this panorama were taken from November 24 to December 1, 2019, between local noon and 2 o'clock post-meridium to ensure consistent lighting. I'm sure all of you have heard about Little Curiosity. The 899-kilogram Mars rover built by Boeing and Lockheed Martin launched on November 26, 2011 aboard an Atlas V 541 rocket, and landed in Gale Crater on August 5, 2012. In 2,694 Martian days, it traveled 22 kilometers and sent about 700,000 photos. The planned operating time for Curiosity was 23 Earth months, but the brave Martian pioneer has long surpassed that period. Thanks to its 3-kilowatt radioisotope thermoelectric generator, it works over time and doesn't depend on solar energy like most other similar devices. By 2020, Curiosity's stay on the red planet had reached almost 8 years. Compare the photos of the freshly built, ready-for-travel rover in 2012 and the experienced dust-covered traveler from 2020. Let's remind ourselves of the long journey of the Martian Science Laboratory, aptly named Curiosity, which means inquisitiveness. In 2012, the rover landed in Gale Crater, named after Walter Gale, an amateur astronomer who observed Mars at the end of the 19th century and described the channels he managed to see on its surface. The main point of interest and the goal for Curiosity was the center of the giant crater, specifically the peak rising from its center called Mount Sharp, or alternatively, Aeolus Mons. Delivering the rover to Mars was a very difficult task, not to mention getting it to the top of the mountain. The route was extremely risky, but thanks to photos taken by the rover itself, as well as orbital images, specialists managed to create a 3D map of the area. An optimal route was found with several points of interest to visit along the way. The first such point was the lowland of Yellowknife Bay. The surface here was once filled with sedimentary rocks brought by water flows from the rim of Gale Crater. This created an environment favorable for microbial life, which almost certainly once existed here. The rocky ridge of Point Lake became a kind of boundary between Yellowknife Bay and Paramp Hills. The height of this small ridge is about 1 meter, but even that height could have been a significant problem. For Curiosity, the initially chosen direction seemed too steep, so it was decided to send the rover along a more convenient route. Curiosity moves higher and ends up in the Paramp Hills, right at the base of Mount Sharp. Then comes the amazing landscape of the Kimberley Formation. The rocks that were captured in this area confirm that the crater had a significant amount of water. Here, the rover finds itself not far from the exposed mineral veins of Garden City. Photographs of this geological formation are of great importance to science, as they clearly show the fracture of veins in narrow and even deeply lying faults. The whale rock, or whale stone, is a vivid textbook example of cross-bedding of rock layers, also known as cross-stratification. This phenomenon represents layering within a stratum at an angle to the main bedding plane. As a result, the sedimentary structures are approximately horizontal units composed of inclined layers. Only water and air currents can have such an effect on the rock. Welcome to the next stop on the Bagnall Dunes route. The landscape here is strikingly different from what we've seen before. You could say it truly becomes extraterrestrial. The Namib Dune stands out in particular, with a height of about 4 meters. These images captured sand dunes for the first time outside of Earth's deserts. Despite the incredible beauty of these places, the sands hide danger. Here, Curiosity found it difficult not to repeat the sad fate of the previous Mars rover, Spirit. In May 2009, it got stuck in a sand trap and couldn't get out. The last contact between Spirit and Earth was on March 22, 2010. Having overcome all the dangers, the path to Curiosity lies through the rocky Murray Buttes Plateau. It was there that the Martian traveler congratulated himself on his 4th birthday by singing the famous English song. Naturally, all the National Aeronautics and Space Administration employees who sincerely care about their ward joined in the congratulations. Finally, our rover descends from the plateau and returns to the Banyol Dunes, finding itself in front of a small rise called Ogunquit Beach. And now, drumroll, Curiosity is at the base of Mount Sharp at a place called Vera Rubin Ridge. The unusual geology of this area was shaped by the wind. From the top of the rise, you get a view of the entire path already traveled. The rover. At a place called Glen Torridon, Curiosity took a break and snapped a selfie. All speculation about the presence of water on Mars was put to rest when the rover reached the Teal Ridge area. Even someone who isn't an expert in mineralogy can immediately tell that the soil here is dried, ancient clay. This journey will be just the beginning of Elon Musk's global plan to turn humanity into a multi-planetary species. To achieve its bold goals, SpaceX needs to establish the first base on Mars, and after some time, the first Martian city. But how will the first colonists manage to establish a base on Mars? What rules will they need to follow? And what will need to be done to build a self-sustaining city on Mars? When the first volunteers arrive on Mars, they will need to find a suitable place to establish the colony. It is known that the surface of Mars is much more radioactive than Earth's, and the temperature conditions on the surface are also quite different from those on Earth. The average temperature on Mars is about minus 40 degrees Celsius, while the average on our planet is plus 14 degrees. The habitat of the first Martians will most likely be built beneath the surface of the red planet. In the future, if circumstances are favorable, more complex structures may be built on the surface. It is planned to cover them with a thin layer of water, which should protect against radiation. Nevertheless, delivering a huge amount of materials and water to Mars to build this technological marvel will require massive financial investments. If the first Martian settlement is destined to turn into large cities, the settlers will need to use materials found on Mars. Fortunately, there are plenty of useful resources on Mars. The surface of the planet contains metals such as iron, magnesium, and aluminum, and electricity can be generated using solar collectors. Oxygen is present in the planet's atmosphere, and the ice beneath the surface can provide water. But once the Martians start extracting these resources for their own use, who will become the true owner of this wealth? In 1967, the United States, United Kingdom, and United States SR signed the Outer Space Treaty. According to it, no state can claim ownership of a celestial body or any part of it, and the sovereignty of states extends only to the space objects they have directly launched. Thus, the inhabitants of Mars will be able to manage their own resources and even create their own laws regarding their use. So far, everything looks very promising, but history teaches us that creating a new colony is always a risk. In May 1607, 104 people arrived in Jamestown, the first English settlement in what is now the United States of America. By January, just 38 people remained. Most died from disease and hunger, others from attacks by Native Americans. Establishing a settlement on another planet will be even harder, perhaps nearly impossible. Feasible. Many scientists are convinced that the time for colonizing other celestial bodies simply hasn't come yet. Astronomer Vladimir Georgievich Surdin argues it's easier and more effective to focus on colonizing and developing the Sahara, Antarctica, or Greenland. There are still areas on Earth that are much easier to develop. Just think of the almost uninhabited Siberia and the basins of the world's oceans. To protect ourselves from conflicts over mineral resources, colonists must create a shared economy before arriving on Mars, based on trading local resources or supporting a new Martian currency. Naturally, for this economic model to function properly, strong local leadership will be required. At the same time, the first settlers have a chance, by remembering the mistakes of their predecessors on Earth, to create a much fairer model of social organization. Elon Musk suggests that the best form of political regime for Martian colonies would be direct democracy, where everyone can cast their vote to approve or reject a decision important for the entire colony. He believes representative democracy, long present in many countries on Earth, is prone to corruption and unsuitable for young Martian settlements. Another problem is the possible threat of war. The settlers will face a severe shortage of resources if, for example, the systems for extracting water and minerals do not work as efficiently as expected. Besides, imagine the mental state of a person who finds himself so far from home. The more colonists arrive, the more divided they may become along linguistic, national, and ideological lines. Without proper control, all these factors can lead to complete chaos, a surge in mental disorders, and, unfortunately, war. For now, it's hard to call Mars a hospitable home, but just imagine the first generation of children born on Mars. For them, it could very well be a true home. Underground shelters, sandstorms, and radiation will be as familiar to them as city streets, oceans, and snow-covered mountains are to us. For them, Earth will always remain a foreign world. It's hard to say now whether the endeavor of Elon Musk and all those who dream of taking humanity into space and settling other worlds will be successful. But the idea that such a great dream could help unite humanity seems undeniable. Perhaps they lived with all their problems here on Earth, but maybe by coming together for such a grand goal as the colonization of Mars, we can forget about earthly prejudices. Like if you believe that human cities will one day rise above the Martian lands, and write your thoughts in the comments. What other problems might the first inhabitants of Mars face? And what do you think could solve these problems? Stay tuned for more. Martian Dust Devil in Gale Crater, Sol 1597. This pair of images shows the effects that occurred in a single Martian day. The photo demonstrates a sand wind blowing under the rover's bottom. This photo transports us to ancient Mars, revealing the sand wind. This mesh of small polygons on the surface of the Martian rock at the right edge may have formed as a result of cracks in drying silt more than 3 billion years ago. And here's another interesting shot. In the foreground, you can see purple-tinted rocks near the rover's location at the end of 2016 on Mount Sharp. Would you like to take a look at the iron-nickel meteorite struck by the rover's laser on October 30, 2016? It's worth noting that the dark, smooth-surfaced rock was meticulously examined using laser pulses and confirmed to be an iron-nickel meteorite. This is a 360-degree panorama from the rover on Mars. This is exactly what our gloomy neighbor looks like. In this self-portrait of the Mars rover, the vehicle is shown at the drilling site of Kela in the Murray Buttes area on Mount Sharp Butte, M9A in Murray Buttes on Mars. The top of the hill in this scene from the mass camera is about 5 meters above the rover and 5 meters southeast of it. Do you want to see pictures from the Farewell to Murray Buttes series? Here they are. This photo shows a hill outcrop with layered rocks in the Murray Buttes area on Mount Sharp. By looking through all the suggested pictures, a person who has never visited Mars can get a rough idea of what landscapes await the colonists who dare to settle on the red planet. Not a very hospitable landscape, is it? And the weather isn't pleasant either. There's only one thing that might be comforting. Maybe, after thousands of years, we'll manage to terraform our dusty neighbor and turn it into a clone of Earth. So, until that happens, hurry up and enjoy the authentic Martian, authentic landscapes. Actually, you know what? That's already too much information for today. Let's continue the story in the next video. And to make it happen, perform the magical triple ritual. Move the almighty cursor to the big thumb under this video. Subscribe to the channel and click the bell to turn on notifications for new content. To do this, just tap this button and click on this bell. Do this and the universe will definitely reward you. Thank you for your attention and see you soon. Subtitles created by Dimitor Zak.